Oftentimes when you are doing calculations and you hear a teacher going through a calculation, we will refer to something called state functions or state variables. And what we mean by a state function or a state variable is it happens to be a measurable quantity about matter as it's just sitting there doing absolutely nothing. So it tends to be measurements like mass, volume, length, pressure, temperature. All of these things can be measured as matter just sits there and does absolutely nothing but just sit there. And these are important because as scientists talk to one another so that you can repeat an experiment, you need to know the conditions at which things were done, because all of these state functions will influence the way chemicals react and the way your outcomes and your reaction products and everything can be affected by these. So it's important to keep them straight. Now, the big lesson on state functions. All state functions, in order to be a state function, are what we call path independent, meaning it does not matter about the history of the substance on how you measure that particular state function. I'll give you an example. Temperature. The temperature of something absolutely does not matter what it used to be. Doesn't matter if it used to be cold and now it's warm, or it used to be hot and now it's cold. The facts are, when you talk about the temperature being 25 degrees C or 77 Fahrenheit, we know exactly what you're talking about. We know what that function is. And that's the importance of a state function. It is not path dependent. There are functions that are very path dependent. And when you get into thermodynamics, you will see some of these functions. The most important ones for us are heat and work. Those definitely depend on how you go about doing something. To go from state 1 to state 2, the heat and the work will vary depending on how you do it. So, a state function is nice because it defines state 1 and it defines state 2. The difference between state functions, which we call delta state functions, you'll see them like delta P for the change in pressure, delta V for change in volume. Those are simply a difference between what you measure here and what you measure here. Heat and work are path dependent, and so those will have to be calculated in a little bit different way. But all of these state functions, we use them and calculate other state functions. It turns out everything's interrelated. And that's what you're going to find in every single unit that you cover and all the different chapters that you go through in chemistry, is we relate one state function to another. So if you change one, you end up changing another. And that's the importance of knowing what we mean when we say, know what your state functions are and know how to calculate them.